welcome you back to this lecture series of multivariate calculus. So in this lecture I will talk about the Lagrange multiplier. So this is one of the important part of this multivariate chapter. So this is also one last part of this multivariate thing. Now why it is so important of this Lagrange multiplier? So let's just understand this thing. Suppose we have this function u of xyz, okay, and here is the same problem that I have to find out the maximum minimum, okay, like the previous lecture. But here is one condition that this xyz satisfying this relation. So there is another function that is phi of xyz. So it is basically function of three variable xyz, and this xyz are also satisfying this equation. So this is basically one constant, and for this function how we can find out the maximum minima, or let's say some problem, okay. So the rule is that so here rule is that I have to, so I'll talk about the working rule that how we can find out for this case. So you have one function u, let's say some that is function of some independent variable xyz, and that xyz also related by some other relation that is phi. Now for that case how I can find out the maximum minimum value? So I construct another function that is capital A, that is the combination of the first function that is f of xyz and plus where lambda is some constant, okay, and with the relation, the function of relation and function between the xyz. After that I will find out the partial derivative of this function with respect to x and y and z, okay. Then I will equate each of them equals to 0, the same case we have done in the previous lecture. Then after that I will solve this one by one, and but I will keep track that these variables satisfying this relation phi of xyz, okay. So let's see one example, then the idea will be much clear. Suppose we have one function, let's say this one, x cube x square b cube y square plus c cube z square, okay. Find the stationary value. I have to find the stationary value subject to the condition. So here you see the condition, that is the relationship between the x y z. So x y z are satisfying this equation, and I have to find out the stationary value of this at that point, okay. So first I will construct that function that is capital F, that is constitute of u, that is the function of xyz, and their relation that is equals to 1 by x, 1 by y, y by z. Then I can find out the Lagrange multipliers, that is this one, f of capital F is equal to small f, this one, right. Now I'll plug in all this value. F I know this one, and I know phi, that is this term, okay. Then after that by the working rule I have to partially differentiate this one with respect to x, y, z respectively. So first I partial derivative by partial derivative of this function f I will get this one, okay. From the next equation I'll get this, and the last equation del f del z I'll get this one. Now my aim here will be to remove the lambda by with the help of the given relation. So here I am just doing the simple calculation. I am finding out the lambda, okay. Then I can get also this relation from this equation, right? Because if I divided this one by 2 and take the cubed root both sides, then it will be ax equal to lambda by 2 1 by 3, and it will be by lambda by 2 1 by 3 and so on. So this is basically I have denoted that lambda by 2 1 by 3 that is equal to k. So they are related, all this ax plus by equal to by is equal to cz, that is equal to some k, some constant. Now from that equation I can find out what is x, k by a, and y, k by b, and z, k by c. Now I plug this x, y, z value in the given relation, that is 1 by x and 1 by y plus 1 by z equals to 1, or from this things I can get the k value. Okay, so this is the approach. By using that I can find out the unknown k. Now I plug in this k in the previous equation. So in this equation if I plug in, that is I know that is a plus b plus c, right? So I can find out what is x, that is a plus b plus c by a, and y equal to a plus b by c by b, and it is divided by c. Now if I by the stationary value, then it will be basically just plugging all these x, y, z in the given function, and I will get this value a plus b whole to the power q. That is one of the nice example of application of the Lagrange multiplier. See you in the next lecture. Thank you.